we're now going to look at how to add vectors. And you've already seen this a little bit. So we're going to start with, for example, our vector that we had, vector A, like this. And we know it's made up of its two components, right? The x and the y component. So that's the y part and the x part. If we add a second vector to A, let's say it goes off in sort of this direction. Oh, I guess I'll make it a different color. There's B, for example. And I want to know what the sum of these is. We already know that in order to add the vectors, we add them up like so. We put them in, actually, did we already say that? We already know that we put them like so. We take these two vectors, we line them up as if we're walking from A to B, and then all together that gives us then our vector C, which is like that. And that gives us a way to graphically determine the value of the sum of A plus B. C is A plus B. But if we're actually going to find the numbers, find it analytically, then we add up the different parts. And so if we look at this in terms of its A and B components, we can see that the x part of C is made up of the x parts of A and B. So Cx is equal to Ax plus Bx, and similarly, Cy is equal to the y parts, is equal to Ay plus By. So in fact, when C is the sum of these, what it really means is that we add the components. And so C becomes Ax plus Bx in the I hat direction plus Ay plus By in the j hat direction. And if B had pointed down, for example, had a negative component, we'd have to make sure and build that negative sign in. Okay, so let's do an actual example here. And we're going to go to, in chapter 2 of our book, this problem. So we have a situation where we have a small plane. So this is north, and this is going to be east, which is going to be my x direction, and y. And so we have something that's going in 60 degrees, so like this, north of east. And so that's 40 kilometers. And this one is 60 degrees. That's our first vector. And then our second vector is going to be, we'll start it from here because we're adding these together at about a direction 15 degrees north of east. So that's going to be a pretty slight angle there. This is 15. Wait, oh, it's only 30 kilometers. So let's make that a little like that. So 15 degrees, that may be a little small, and we'll make this 30 kilometers. Now, we can try to find this graphically where we're sort of just estimating these. So if I want to find this, that's what it's asking. Find the total distance and the geographic direction. That is theta, right? The theta that we have here. And so the total distance is obviously going to be less than 70 kilometers because that, as the crow flies distance, is going to be less. But it's not significantly less. So I would estimate, if we call this our A vector and this our B vector, and so this is our C vector, I would estimate, just looking at it, having drawn it here, that, I don't know, it's maybe 60 kilometers or so. And the angle, well, it's not as big as 60, and it's certainly bigger than 15, maybe 40, 45, somewhere in there. Okay, so we'll say theta is around 40 to 45 degrees. It's useful to kind of estimate this to know if your value is good based on your diagram, but to actually get the numbers, then we're going to use the component notation that we developed above. So we're going to go up here and we're going to look at this, and this involves first finding the components, the x components of a and b and the y components of a and b. So we first get a little practice with our vectors here. We say x is going to be equal to the magnitude of a, that is our 40 kilometers, times, looking at this angle, the x part, this is ax is distance, that is the adjacent one, so it's going to be a cosine of 60 degrees, because if we look over here, cosine of 60 degrees is adjacent over hypotenuse. So ax over the a vector. If you prefer, we can say the magnitude of a. And ay, similarly, again, ay is this opposite side, is a sine of 60 degrees. And so if we put these numbers in, then what we get is that a times cosine of 60 degrees is actually 20 kilometers, and ay, that's a sine of 60 degrees. That number I have to look up, 34.6 kilometers. Okay, so my a vector in all of this is these parts. It's 20 in the I hat plus 34.6 in the j hat, all with units of kilometers. Now I just need to do the same thing for b and then start collecting the pieces, add up the things that are similar. So if I do the same thing for b, I have b is equal to then 30 kilometers, the magnitude of that, and again the x component over here is the adjacent, so that's going to be cosine of 15 degrees in the I hat direction, plus 30 sine of 15 degrees in the j hat direction, kilometers. And so b, typing these things into my calculator, I get this is 29.0 I hat plus 7.8 j hat kilometers. Okay, so now I have my a vector and my b vector, and I can add these together. So I can get then that c, after all of that, c is just adding the x part. So 20 plus 29 is 49.0 I hat. And then I add these two parts, plus, let's see, that's a 4, carry a 1, I think that's 42.4 j hat kilometers. And so that's the value of c, but that tells me the components of c. That tells me that c is 49 this way and 42.4 that way, kilometers. And so to get the magnitude of c, this is a Pythagorean theorem, so we're doing all of our vector stuff at once here, but this is a Pythagorean theorem. The magnitude is the square root of the sum of the squares, 49 squared plus 42.4 squared kilometers. And when I plug that into my calculator, I get 64 kilometers. Okay, I estimated about 60. I knew it was less than 70, but it's actually pretty close to 70. And then to find that angle, right, we look at this angle, and I can tell that if I look at theta, I've got the 42 and 49, and so tangent of theta is equal to 42.4 over 49.